everyone, I'm Dr. Jagadha, Associate Professor in the Department of Mathematics. We are going to discuss the topic about problems on finite Fourier transforms. In this topic, definition of finite Fourier transforms, problems based on finite Fourier transforms. These two topics in detail we will discuss. The definition, how we can define the Fourier transform which comes under finite. It depends upon, that is, the function f of x which is defined in a finite interval where x lies between 0 to L. This is very important, that is the length of the interval x starting from 0 ending up to L. Then we will call it as it is finite Fourier transform. This finite Fourier transform, which is also known as continuous periodic function. Now, the definitions of finite Fourier transforms. That is, regarding finite Fourier transforms, what are the related formulas are there? First, finite Fourier Sine transform. That is, capital Fs. Here, capital F represents Fourier transform. The small s represents Fourier sine. That is, mathematically the notation is Fs of f of x. We will read this as Fourier sine transform of the function f of x. In other way, capital S of n, which is equal to integral 0 to L f of x sine of n pi x by L dx. Here L, here also it is placed L. That is, in the formula, the two places L is occurring. These are the small thing, the variables, how many places occurring. If we are keeping in the memory, it is very good. The next one, inverse finite Fourier sine transform. In this formula, f of x equal to 2 by L summation n equal to 1 to infinity capital F S of n sine of n pi x by L. The topic we are discussing about finite Fourier transform, but here infinity it is there. So this infinity, if it is there, then how it comes under finite? The starting just now, that is the introduction, we made it very clear that x lies between 0 to L. If it is there, then it is finite. So x it is mentioned. Whereas here n it is there. This point we have to be very careful. That is, x if it lies between 0 to L, then it is finite. So we completed here regarding Fourier sine and inverse Fourier sine under finite. The next one is finite Fourier cosine transform formula. That is, capital F C of f of x. We can read this Fourier cosine transform of the function f of x, which is equal to f c of n. It's nothing but integral 0 to L f of x cos of n pi x by L dx. Now, inverse finite Fourier cosine transform formula is f of x equal to 1 by L fc of 0, that is Fourier cosine transform at the point 0 plus 2 by L summation n equal to 1 to infinity fc of n cos of n pi x by L. So now, regarding sine, two formulas, cosine, two are there. So these four formulas to keep forever we should not forget. So small the technique we can keep in our mind. Wherever the inverse is there the summation symbol is occurring, and inverse if it is there, the function f of x equal to, we are writing, the Fourier is inside the summation. So these are the points that is comparing each and every formula. What is the difference between the formulas we have to note down. Then it is very easy to understand. Now, we will concentrate the problems. The first problem is find the finite Fourier sine and cosine transforms of f of x equal to sine ax in the interval 0, pi. Solution. The question which is given, the function is f of x equal to sine ax, and it is mentioned also the word finite is there. Suppose in case this word finite, if it is not given also, looking at the interval 0, pi, we have to select finite only. Because if infinity is there, we will go under infinite Fourier transform. So we will do the problem. So finite Fourier sine transform formula is, this question contains two parts. The first one is finite Fourier sine. The second part is finite Fourier cosine. First, we will do the first part. So the Fourier sine transform of the function f of x, in other way, fs of n, which is equal to integral 0 to L f of x sine of n pi x by L dx. Case 1, that is, here the question is given, that is, our given function is f of x equal to sine ax. The formula Fourier sine, that is, formula is f of x sine of n pi x by n. Our L is pi, so the pi getting cancelled. So integral f of x sine nx. This f of x is nothing but sine ax. So sine ax is there, sine nx is there. In these both, a is there, n is there. The case 1, suppose this a and n, they are not the same. That is, they don't have the same value. Mathematically, how we can say that? A is not equal to n. So, the first case, if a is not equal to n, how to deal this function and how to do the finite Fourier Sine transform. So, the Fourier Sine transform of the function f of x equal to capital S of sine ax. Our problem L equal to pi. So in the formula 0 to L, according to our problem, the L is pi, with L is replaced. So we know very well in the formula the two places L is occurring, that is here and here. That's what we have to, while learning the formulas, where the variables and the letters are occurring, how many times also. So after substituting, whether we substituted those many times in a correct way, or we can check it. So the two times, so L is replaced, here also L is replaced. Now this pi getting cancelled. So after getting cancelled, so 0 to pi sine ax sine nx dx. It's fine. Now 0 to pi sine ax sine nx dx. This to be solved. This is one trigonometric term, sine ax. Another one is sine nx. Both are trigonometric but different, sine ax and sine nx. Two trigonometric terms are there. How to do the integration? So one point we have to, that is for the integration purpose, we have to strongly, we have to remember. Otherwise, to do the integration, more the problem which will come under complicated way, we should not go. So while doing the integration, first we have to notice it if the trigonometric terms under product, two terms are there. Otherwise, one more thing, if the trigonometric terms, if they have powers, then relevant trigonometric formulas to be substituted. In that angle, now here sine ax is there, sine nx is there. So the two trigonometric terms under product. So the relevant, the trigonometric formula we selected are 2 sine A, sine B, which is equal to cos of A minus B x minus cos of A plus B x. Now our A in the formula capital A is there. We will do comparison with our which problem we are solving. So the A, here our problem AX is there, and capital B, NX it is there. So the AX and NX. A is taking, we have to replace, that is in this, the right hand side of the formula, the capital A is replaced AX and B should be replaced NX. So here AX minus NX, so A minus N of X. Similarly here minus cos of AX plus NX. So cos of A plus N X. So we can do it. How to substitute we have seen just now. Before that, this formula when we are comparing, a very important point to be noted, that is the left side 2 is there, but wherever in our problem the 2 is missing. So suddenly we can't introduce 2 as it is. On its own way it is not possible. Mathematically we have to balance it. So for that, so multiply and divide by 2 we have to do it. So now it is exactly fit our trigonometric formula. So this 1 by 2 as it is we are writing 0 to pi cos of, here it is A minus n of x minus cos of a plus n of x. Now we have to do this integration. So before doing the integration, cos x, immediately everybody we will tell the integration is sin x. But sin x, the x coefficient is 1. So divided by 1 it is there. The concept is very important. In the same manner, now cos of a minus n of x is there. Then sin of a minus nx divided by this coefficient of x. Coefficient of x is nothing but a minus n. So it is written divided by a minus n minus, we want it here, cos of a plus n. So the cos of a plus n, the dx, sin of a plus n x divided by the coefficient of x. The coefficient of x, leaving x, the remaining we have to put it divided by. So very simple way, the integration in, we wanted cos of a plus n of x dx. That is cos of some term. Then sin of that's some term divided by, with respect, with what we are doing, with respect to x we are doing. So when we are doing with respect to x, so the coefficient of x we want it. The coefficient of x, we will leave x, the remaining will become the coefficient, so that it is written divided by. This is the best way to do the integration without any careless mistake. Yes, then 0 to pi. Now, our upper limit is pi, lower limit is 0. So, sin of a minus n, x place we will substitute pi divided by a minus n. Here minus sin of a plus n, here x is replaced by pi divided by a plus n. So we completed the upper limit substitution. The limit formula is upper value, limit value minus lower limit value substitution. This is the negative sign formula sign of the limit formula. So here we completed our upper limit formula minus. Now we will move to concentrating on our lower limit, that is the value 0. So the lower limit is 0. So in the place of x, we are going to substitute. So when we are substitute in the place of x, it is becoming sin 0. We know very well sin 0, the value is 0. And this sign is related to problem. So here problem sign. Here x is replaced by our lower limit value 0. So sin 0, again it is 0. So upper limit, lower limit, substitution is over. Between upper and lower, the formula sign. So 1 by 2 sin n pi, the value is 0. Here also the value is 0. Completely upper limit is 0. For minus sign, this is 0. So when the case, if a is not equal to n, we are getting the value 0. Next, we will move to case 2. The case 2 value is, the first case we concentrated on not equal. Suppose if they are equal, then how to do? So capital Fs of f of x equal to our function is sine ax. That's what we did. The case 1 we completed. So this is our function. So 0 to pi sine ax sine nx dx. This a and n, if they are equal, that is a place we can write n or n place we can write it a, both are equal. So we substituted, that is a place n, it has become sine square nx dx. Here also, to do the integration, the trigonometric term sine, which has power. If the trigonometric term, it has power, the corresponding, the trigonometric formula to be substituted in that particular place. So the formula is nothing but 1 minus cos 2a by 2. So here this formula, what is the 1 by 2, we have taken out. So we have to do, that is the formula and our problem. In the formula, capital A is there, and this capital A, what is the role which is playing in our problem? The role is nx. So we are substituting here, the 1 is 1 minus sign here. So cos 2a. The divided by 2 only, we kept it out. So now we will do the integration, that is 1 by 2. Here 1 into dx, it's nothing but x minus cos 2nx. Cos 2nx, the integration is sine 2nx divided by x coefficient. So we will leave x, the remaining is 2n. It is integration we are doing, so divided by 2n. Very simple way we can do the integration, 0 to pi. Now this 1 by 2 as it is, x place we are substituting, concentrating on upper limit. Our upper limit is pi. So x place substituting, because we concentrated the integration with respect to x. So x is replaced by pi minus, as it is, sine 2n pi, the value is 0. So here completely it is written upper limit substitution. It is not noted here, it is not written here regarding the lower limit substitution. The reason is, it is neglected here. So why it is neglected here? X place we are substituting 0, it is 0. Sine 0, 0. So completely the lower limit value, when we are substituting, it has become totally 0. That is the reason it is not mentioned here. So now pi by 2 is the value we are getting for the case 2 when a equal to n. So we listed here, that is our finite Fourier sine transform for the function sine ax, case 1, that is when a is not equal to n, we got the value 0. If a equal to n, we got the value pi by 2. So the question, the first part of the problem of our given function, we finished. So the second part of the first problem is finite Fourier cosine transform formula. So the Fourier cosine of the function f of x, in other way, capital Fc of n, which is equal to integral 0 to L f of x cos of n pi x by L dx. So L is in the two places occurring. N, it is here only one place it is there, and this f of x, what is a given question that we have to substitute in the place. So each and every the formula, the terms are playing which role, how many times they are playing the role. If you notice it, then we never forget the formula. So this is our function, that is f of x equal to sine ax. That's what we are concentrating. The second part we are going to do now. So the second part is, so this is our f of x here. So we will replace it. Cos of n pi x by pi. This pi getting cancelled. That's what it is written, cos nx sine ax. So sine ax cos nx. Two trigonometric terms are there. So the trigonometric terms, two terms under the product, then immediately relevant trigonometric formula to be replaced. To replace that, the formula in the format of 2 sin A cos B format it is there. So exactly to fit the trigonometric formula, here 2 is required. So multiply and divide by 2 will do it. That is, this is the formula. Here 2 sin A cos B it is. But in our this integral, only sin ax cos nx is playing. 2 is missing. So multiply and divide by 2, it is done. Fine. So 2 sin A cos B. The capital A, which plays a role in our problem, ax. Capital B, in our problem, nx is playing the role. So sine of ax plus nx. X is common. So sine of a plus n of x plus sine of, here substituting a minus n of x. So that we can see it here, it is written. Now we have to do the integration. Sine of some term, then sine integral is minus cos of that particular some term. Very easy way. So minus cos of a plus n of x divided by the coefficient of x to be written divided by. So the x coefficient is, leave x, the remaining we will put it down. So a plus n. Here also sine of the term. So cos of that term divided by, in that term, what is the coefficient of x? The coefficient of x is a minus n. So that we will write it a minus n. 0 to pi. So now, here the minus, the first term minus sign is there. The second term minus sign is there. Put together, we have taken the minus sign outside. That is the reason it has become, this negative sign, it has become positive. So this is the last step of the previous slide. So minus 1 by 2 of cos of a plus n of x divided by a plus n plus cos of a minus n of x divided by a minus n, 0 to pi. So now we will concentrate this upper limit. So minus 1 by 2, wherever x here is there, here is there. So the x is replaced by our upper limit. So cos of a plus n of pi, the down part we didn't touch at all, as it is we are writing. Because our target is the upper limit to be substituted in the place wherever x. So here also we substituted. Here the denominator 1, it is listed as it is. So we completed the work regarding upper limit. Now we will move to the lower limit substitution. Before that, we know it upper limit minus lower limit. So this is the minus regarding formula sign. So the lower limit is 0. So x place we are substituting. So cos 0, the value is 1. So 1 by a plus n. This plus is as it is. Here the cos 0 is 1. 1 by a minus n. Upper limit, limit formula sign between that. Upper and lower between the formula sign is negative, lower limit job. Everything we completed. Now, if it is cos n pi, the value is minus 1 power n. But we have, instead of n pi, in the place we have a plus n of pi we have. So that is a reason it is written minus 1 power a plus n. The down part is no change at all as it is. Here cos of a minus n pi. So that is minus 1 power a minus n. The down part, there is no change at all. This minus sign as it is. Here we are taking the minus inside, minus into plus, minus. Now, this step, now just note it is written this step. Some difference it is there. That is, everywhere the same as it is written, this term as it is, this term as it is, even here as it is, only the change is in this term, the change it is there. That is, minus 1 power a minus n is there. We replaced that minus 1 power a plus n. Suddenly this change we brought in. This is first mathematically it is correct. Is it we can replace like that? That we can see it now. So minus 1 power a plus n, which is equal to minus 1 power a minus n. This only we replacing we did. That replacing doing this, both the values should be the same. That is, we can write according to the exponential law. We know it, a power m plus n can be written as a power m into a power n. This is a small exponential law we studied in lower classes. So using this formula, minus 1 power a into minus 1 power n, which is equal to minus 1 power a into minus 1 power minus n. This getting cancelled. Minus 1 power n equal to minus 1 power minus n. We will take some n value as 2. So we will substitute here minus 1 square. It is becoming 1. So we know it, negative power square is 1, or minus 1 into minus 1, 1. Here minus 1, minus 2. We are taking just these both are same or not. So this is minus 1 square. Again, this is 1 here. So this both. So in this place, this we can replace, or this we can replace. So that is the reason the replacing we have done it. what we have done it is mathematically correct. So this is purpose only, that explanation which is given. Now we can see here, now the substitution part we are going to take place. That is, here we say this value a plus n put together, if they are even numbers, two possibilities, even or odd. We are going to take the value 1 to we are going to take. So suppose a plus n, if it is taking the value even numbers, then suppose this is 2, then what it will become? So minus 1 square, it will become 1 by a plus n. This is also 1 by a minus n. In this place this place this one. Already here minus 1 by a plus n is there. So this getting cancelled. That's what it is written. When a plus n is even, we are getting the value is 0. Whereas this a plus n is the value, it is taking as minus, then we can take the odd number 1. So it will become, this value will become minus 1 by a plus n. So minus 1 by a plus n, here also minus 1 by a plus n. Put together minus 2 by a plus n. Similarly here also we are substituting 1. So it will become minus 1 by a minus n. This and this, it will become minus 2 by a minus n. So minus minus, here already outside one minus is there. So it has become positive. So 1 by 2 of 2 by a plus n plus 2 by a minus n. This we will do the cross multiplication. So it is becoming 2a minus 2n plus 2a plus 2n. So this both getting, so 2a minus 2n correct only. It's becoming 4a. Outside one 2 is there, so it is cutting. It is becoming 2a. So the down one is a plus n into a minus n. It's nothing but a square minus n square. Otherwise, we know the formula also, a plus b into a minus b, a square minus b square. Yes, we completed the problem, that is a Fourier cosine of the function sine ax. If a plus n is even, we got the value 0. If a plus n is odd, we got the value 2a by a square minus n square. So we completed the first problem for the function sine ax. Fourier cosine we did, Fourier sine also we did. So we will move to the second problem. The second problem is find the finite Fourier sine transform of f of x defined by x lies between 0 to pi by 2. The function is x. X lies between pi by 2 pi. Then the function is pi minus x. So the first we will concentrate finite Fourier sine transform formula is. So the capital Fs of the function f of x equal to, in other way, capital S of n, which is equal to integral 0 to L f of x sine of n pi x by L dx. Just we will cross check it. We have written the formula correct or not. Yes, L is 2 places, N 1 place. Here f of x to be replaced according to the question. What is the function is given. Fine. Now the same as it is written here. Once again it is repeated. Yeah. According to our condition, the formula 0 to pi is x lies between 0 to pi by 2. X lies between pi by 2 to pi. This is the limit, the condition which is given in our problem. So 0 starting, ending is pi. So 0 to L is the formula. So 0 to pi is our formula length of the interval. So 0 to pi. Our L is pi. So here we are substituting pi. Pi cancelled. So we got it sine nx. Here f of x is there. But in this problem, ours for this f of x is different. For this f of x is different. So first we are writing 0 to pi by 2 f of x sine nx dx plus pi by 2 to pi f of x sine nx dx. It is very clearly given if x lies between 0 to pi by 2, the function is x. Whereas x lies between pi by 2 to pi, the function is pi minus x. How to read? Here it is clearly mathematically this integral 0 to pi by 2. We are reading that is as it is, but what is the meaning of it? That is integration we are doing with respect to x, that is x lies between 0 to pi by 2. For that, what is our f of x? We are searching in our question. So when we are searching in our question, that is exactly fitting this one, then the f of x is x. So we are going to replace this f of x as x. And this f of x, that is x, lies between pi by 2 to pi. It is here in our problem. So f of x, we are going to replace by pi minus x. So we replaced it. That is f of x is taking the position of x. Here the f of x, the position is pi minus x. So we have done it here. It is the step which is repeated here. So now thus two integrals are there. The first one is 0 to pi by 2. The second one is pi by 2 to pi. Pi minus x is there. That we split it. That is pi into sine nx as one integral. X into sine nx as another integral. So put together first integral, second integral, third integral. Three integrals are there that we named that equation as 1. So now we have to do these three integrals. So this is the equation 1, first integral. So the first integral is 0 to pi by 2 x sine nx dx. Very simple way. That is, first we will notice that integration. Integration, the term is x and sine nx. One is algebraic related, another one is trigonometric related. Algebraic and trigonometric combination, it is there. Very easy way the integration is, simple way. Algebraic one, we will write it. x, the differentiation is 1. 1 differentiation is 0. Sine nx, 0. Because 1, we know it, the differentiation of any constant is 0. So the work is over related to the x. The next one is sine nx. The trigonometric, the term sine nx, we will do the integration. So the integration is minus cos nx divided by integration. Then we have to write the coefficient. So x coefficient is n. Again we will do the integration. That is minus cos integral is sine nx by n, but already n is there, so n square. So again, once again, we no need to write at all because the differentiation side already the value it occurred is 0. So anyway, if you write also, that is meaningless. So we will stop up to here. So this into this into this we have to do. This is a method, very simple way we can do the integration. So that we will see it now. Yes. Now we can notice here the animated one, the blue color, it is there. In the blue color, this is the algebraic one. The x is there. The differentiation, this one. The sine nx, we integrated. So that term is here. Again we integrated. The term is here. That is, we know it. Minus is minus. Cos integral is sine nx divided by n. But already here n is there. It has become n square. We stopped the integration here. The reason is we no need to continue because 1 again the differentiation is 0. Suppose here any other term is there, we will continue. It goes on. So actually here we can see it. The beauty of this integration is the algebraic one is selected for differentiation, that purpose only. If you select the algebraic one, differentiation only, the problem comes to an end. If you select the trigonometric one, never-ending processing. Yeah. So now, so each and every the mathematical formulas, the beautiful concepts are there behind. Now, we have to integration is completed. Here 0 to pi by 2 to be written. Here the term, if you're noticing, 2 terms are there. The first one here, the term, whereas the second one, if you're concentrating, here minus sign is there, here minus sign is there. 2 signs are there. Before substituting, here only we can substitute, that is upper limit is pi by 2 minus the lower limit value we will substitute. But to avoid the careless mistake, we should not give room for committing errors, mistakes. The entire problem will be collapsed. So to avoid those, to block those rooms, what we have to do it the simple way. So now here plus is there, plus into minus, 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 it has become plus. Now this first term is negative sign, second term is positive sign. So every term we are telling a single sign. Then we can substitute. The stage it has come after simplifying like this, as a each term single sign, we will substitute the limits. That is, upper limit is pi by 2. Our lower limit is 0. So now upper limit in the place of x we are going to substitute. So the substitution part, minus x is taking the position of upper limit value, that is cos. This n we have put it outside 1 by n. The reason we are going to substitute in the place of x only. So cos n, x is taking pi by 2. So cos n pi by 2 plus here 1 by n square. Here it is written sin n pi by 2. The 0 here, this lower part, it is not at all listed here. It is not written here. The reason 0 into anything 0. Sin 0 is 0. So we got it. The first integral result is minus pi by 2n cos n pi by 2 plus 1 by n square sin n pi by 2. The second integral is integral pi by 2 from pi by 2 to 2. From pi by 2 to pi sin nx dx. So now sin nx, so that integration is, the pi is written as it is, sin nx is cos nx, the coefficient of x is n. So that is written, which is divided by n, pi by 2 to pi. So here, that is the upper limit. Our pi is substituted in the place of x. So pi by n cos n pi, upper limit job is completed. The lower limit is pi by 2. So this pi by n, it is written cos n pi by 2. Substitution is over, but here the negative sign is there, but here it is written positive sign. We know it. The limit applying upper minus lower. This minus, formula minus, this minus, problem minus, put together plus. So the second integral, the work also completed. Now we will move to third integral. So the third integral is pi by 2 to pi x sin nx dx. So pi by 2 to pi x sin nx dx. So when we are looking algebra part, it is there. Algebraic term, it is there, x. Trigonometric term, it is there, sin nx. So here the blue color for differentiation, it is colored. Algebraic, the differentiation, it goes on, we are writing the differentiation. Sin nx, integrated one we are writing, minus cos nx by n. Again here we are doing the integration. So minus cos nx is sin nx by n, but here already n is there, it is n square. This sign is alternative signs, that is formula signs, plus, minus. Suppose the term continues. Here we stopped because one differentiation is the next is 0. That's what we stopped in this particular problem. Suppose if it continues, here minus formula is there, we will write plus, again the differentiation, integration, next minus, it goes on. So in the between the terms, the signs are alternative signs. Yes, substitution we have to do it, but we want to avoid our careless mistakes. So we have to make the terms a single signs. Here this is okay, plus into minus, minus, here minus into minus, we have to write it plus. So we made it. So the first term is minus x of cos nx by n plus sin nx by n square. Pi by 2 to pi. So we will substitute the upper limit. That is, in the place of x, we are going to substitute our upper limit. So x is taking the position pi. So minus pi by n cos n pi. 1, 2, 1, 2. The two places we substituted upper limit, only one term is there. Second term, it is not written because sin n pi, the value is 0. So the limit we employed here, then it is written minus pi by n cos n pi. This is the formula sin. The entire thing, the substitution of lower limit value. So the lower limit value is pi by 2. In the place of x, we are going to substitute. So 1, 2. For that, here minus pi by 2. This n, here we are writing minus pi by 2. This n joining is becoming pi by 2n. Here x place pi by 2, it has become cos n pi by 2 plus this 1 by n square, it is kept out. Sin n, x is taking the value pi by 2, it has become sin n pi by 2. Upper limit minus lower limit. Completely limit value substitution is over. Some small simplifications, that is, we have taken this minus sign inside. The first term is written as it is, whereas the second term, minus into minus, plus, again minus into plus, minus. So 1 by n square sin n pi by 2. So this is the result. We got it for the third integral. More simplification is there. Just it is repeated. Without a bracket, it is written. That's it. So the first integral plus second integral minus third integral. That is, we are going to substitute in the equation 1. This we solved it, everything we completed. So the first integral, this is the 1. The second integral, this is the minus sign. The third integral value is written. So we completed the second problem also. Now we will move to the third. So the third problem is find the finite Fourier cosine transform of f of x defined by f of x equal to pi by 3 minus x plus x square by 2 pi, where x lies between 0 to pi. Here the function is, it has some 3 terms are there, pi by 3 minus x plus x square by 2. One is constant, another one is, they are in terms of x. Our x lies between 0 to pi. That is formula 0 to L. Our problem 0 to pi. So our L is taking the value pi. So the finite Fourier cosine transform formula is capital F C of f of x. Fourier cosine transform of the function f of x equal to fc of n equal to integral 0 to L f of x cos of n pi x by L dx. L, 2 places, n, 1 place. this to be replaced by our given problem, what is the function which is given. And we have to do integration with respect to x. In the formula, cosine is there. Compulsory, here cos should be. If Fourier sine is there, here sine will come. Like this, each and every term, remembering, we have to keep an idea. Yes, now 0 to pi, our f of x, which is replaced according to our equation. So it is written here, cos of n pi x by L. So L is replaced, pi, the pi getting cancelled, cos nx. So here f of x, cos of that pi getting cancelled. So it is 0 to pi of pi by 3 minus x plus x square by 2 pi cos nx dx. We will concentrate the integration now. That is the complete, what I am circling here, that is algebraic oriented. This one is trigonometric oriented. Very simple way. First, so we can notice it, just I'm putting the tick. The terms are in to understand the students' understanding level to increase more. The algebraic part, what we are going to do, the differentiation, it is colored in blue color, the animation which is given. So now, algebraic one, what is our algebraic one? Our algebraic one is pi by 3 minus x plus x square by 2 pi. This differentiation we have to do it. The first term is constant, that is 0. So we didn't mention here. Minus, as it is written, x differentiation is 1. X square, the differentiation is 2x divided by 2 pi. So here the differentiation, the first one, we did. The second one, it continues till when the value it is becoming 0, till then we have to do it. Now minus 1 differentiation is 0. So that's what we didn't mention here. The 2 getting cancelled. X differentiation is 1. So 1 by pi. So differentiation, but we stopped the procedure. The reason, we got it here constant. The constant of the differentiation is 0. So the processing is stopped. Next, here this term, the trigonometric term is cos nx. So we have to do the integration. So the cos nx integration is sin nx divided by coefficient of x. So the coefficient of x is n. So divided by n is written. So we can see it. Again, we are doing integration. So the trigonometric one, keep on, we will be doing integration. So which the integrated one are in red color. So again, we are going to do the integration. The minus is as it is. Cos integration is sin nx divided by n. But already here n square before term put together n square into n, it is becoming n cube. We will stop the procedure because before 1, the differentiation purpose we got it constant. So simple one, algebraic one, keep on differentiation. Trigonometric one, but first term we have to be very careful, integrate and we have to write it. Keep on, we have to do the integration. The signs are there. Here first one is plus. alternative signs. If it continues, next we will write minus. Next we will write plus. Next minus. It goes on alternative signs. This is the simple way we can do this integration. Now, substitution. But we won't do the substitution immediately. We will check the signs. First term, single sign we wanted each term. First term, it is written as it is. Whereas the second term, here minus, we made it, that is minus into minus, plus. Here, the third term plus into minus, it is written minus. So the first term positive, second term positive, third term negative, a single sign. Like this doing completely without any careless mistake, we can do the integration. This is actually students should be their beneficial should be more. That is the reason each and every steps, even animation it is written here. Now the limits 0 to pi. So in the place of x, we are going to substitute the integration with respect to x. The upper limit is pi. X. In the place of x, we have to do it. Here x. Sine and x. So x is replaced. Here also we have to replace it. But where the trigonometric term, to save the time, sine n pi is 0. So first sine is there, that we have to catch the point. So sine n pi, the first term, it has become 0. Here pi we are going to substitute. In this place pi we are substituting. Pi cancelled. 2 cancelled. So it is becoming 1. Minus 1 plus 1, 0. So this is also 0. Third one, sine n pi. That is x place, we are substituting this upper limit value pi. So sine n pi. So completely our limit, upper limit value pi, in the place of x we substituted, we got this result as 0. This is our limit formula sign. Now we will concentrate our lower limit, that is 0. So our lower limit is 0. That we will substitute here. Sine 0 is 0. Then this term, it is becoming 0. Because x place we are putting. Now we are in the domain of concentrating lower limit 0. But here this minus 1 is there. The x place only we are substituting. Cos 0 is 1. So it is 1 by n square. Already minus is there out. So it is minus 1 by n square. Here we are moving x place we are substituting 0. Sine 0 is 0. It is 0. Upper limit minus formula minus lower limit value. So minus here minus, we got it 1 by n square. So where n is greater than 0, that is n is taking the value more than 0. So this is our question, that is f of x cos n pi x by L. Our n cos of n pi x by L, our L is pi cancel, cos n x, we got it. Suppose this n is 0, what are the changes? Because this we are telling n is greater than 0, If n which is equal to 0, what are the changes will be there in the given function? So we have here cos n pi x by L. This is the f of x. This place we know it L. This place we know it L. So L is replaced by pi. This is our f of x. So pi cancelled, and our n is taking the value 0. So cos 0 is 1. So this function cos 0, the value is 1. So pi by 3 minus x plus x square by 2 pi into 1. Here completely written. This we have to do the integration. That is pi by 3 minus x plus x square by 2 pi dx. Simple integral formula. That is x power n dx, it's nothing but x power n plus 1 by n plus 1. This is a simple formula using we will do this integration. So now pi by 3 dx, the integral is x. This minus is as it is. X power is 1, that is x dx, power is 1. So x power 1 plus 1 by 1 plus 1, x square by 2. X square by, here this we are doing the integration. The 2 pi is written as it is, we are not at all touching. That is 1 by 2 pi. X square, in the formula x power n is 2. So x cube by 3. So x cube, this 3 into 2 pi put together 6 pi. 0 to pi. So the substitution we have to concentrate. So pi by, here x is taking the value pi. Here x is taking the value pi. Here also taking the value pi. So wherever x, we are substituting the upper limit, the value pi is substituted. So the first one, it is becoming pi into pi, pi square, the 3 is written as it is. Minus, it is no change at all. This is pi square by 2. Plus, here pi cube divided by 6 pi, this both getting cancelled. Then pi square by 6. So this we have to do the cross multiplication. We got it here. So the cross multiplication is here pi square by 6. This value is minus pi square by 6 equal to 0. So the problem finite Fourier cosine transform we completed. More finite Fourier sine transform formula, we will do it now. So the Fourier sine of the function f of x, which is equal to capital F s of n. So integral 0 to L f of x sine of n pi x by L dx. The f of x, which is replaced by pi by 3 minus x plus x square by 2 pi sine of n pi x by L is replaced by pi. So now the pi getting cancelled, sine nx dx. Algebraic, trigonometric. So we have to do the integration with respect to x. The limit range from 0 to pi. So the algebraic one, It is animated in blue color. So the algebraic, the first term is pi by 3 minus x plus x squared by 2 pi. The differentiation, the pi by 3 is constant. It is 0. It is not mentioned. Minus, as it is, x differentiation is 1. X square, the differentiation is 2x. The 2 pi as it is. The 2 we will cancel it. So here x by pi, this differentiation is, pi is as it is, x differentiation is 1. So the algebraic part, keep on, we are doing the differentiation, then only problem will comes to an end if we select the algebraic one for differentiation. Because anyway we will be getting the constant, the differentiation of constant is 0. The last one is constant, its differentiation is 0. The last, that's what we stopped the procedure up to here. Next, ours is sine nx. The term, we will do the integration. So sine nx integral is, that is the before one, sine nx, the trigonometric term. So sine nx, the integral is minus cos nx, x coefficient is n. Keep on, we will be doing the integration. This term, how we are getting this term? Minus is minus cos nx, the integral is sine nx divided by n. Already n is there, n square. The next one is, here minus is there, but sine nx is minus cos nx divided by n. This minus minus only, here it has become positive. This n, here n square is there, so it has become n cube. The signs between the terms, the signs should be in alternative form. This is positive, negative, positive. If the problem continues, then negative, positive, keep on, we will be writing. According to the problem, it is stopped up to here, 0 to pi. Very simple way, it is animated. Differentiation in blue color, it is shaded to understand more. Integrated one, it is in red color. So we will concentrate now this limit values. So before substituting the limit values, the upper limit is pi, the lower limit value is 0. But before substituting, we have to make up a single term. The term should have a single sign. It is not any mathematical rule that we have to keep like that. Only the thing to avoid the careless mistake. That's it. Now this minus sign, this we will make it plus. This is plus. So we can see it here. The change we brought it here plus. Now 0 to pi. So now in the place of x, we have to substitute our upper limit in the place of x. Here, here, here. This is the first term. In the place of these places where I circled it, we have to substitute. We substituted 1, 2. Here pi square, but down pi is there. So both getting cancelled, it has become pi. This is cos n pi. Cos n pi value is minus 1 power n. Whereas the second term, here this x, Before substituting only, we are noticing cos sine n pi is there. So to save the time, sine is there, n pi, the value is 0. Sine 0 also is 0. First we have to, that point we have to catch to save the time. Sine n pi, the value is 0. Next, 1 pi, it is written as it is. Cos n pi minus 1 power n cube. So the complete, the work, the job related to our upper limit is over. Limit formula. Now we have to focus, we have to concentrate on our lower limit. So the lower limit, the value is 0. So in the place of x, we have to substitute. Where I am circling, we are going to substitute. So this, taking the 0, we are substituting completely 0, only pi by 3 only left over. Minus cos 0, the value is 1, so it is becoming minus 1 divided by n over. Here the complete the term is there, but sine is there. First there we will substitute. Sine 0 is 0, so the second one it has become 0. Next, here 1 by pi, but x place we are substituting 0. Cos 0 is 1, so 1 by n cube. Upper limit minus lower limit value, that is upper limit value pi is substituted, lower limit value 0 is substituted in the place of x. So just that is the term of the step of the previous slide. It is kept again. Now only the simplifications part. So this we will take the LCM. We will be getting minus pi by 6. This it is written as it is. This term it is written here. Minus is written here. This is minus into minus. Put together this term, it has become minus pi by 3 n. This term it has become 1 by pi n cube. So now we can see it, this minus minus it has become plus. So the first one is pi of minus 1 power n by 6n plus minus 1 power n by pi n cube. This minus minus plus, so pi by 3 and this minus we are taking inside, then it is becoming, in just a minute, so it should come here minus, this part it should come minus, so minus 1 by pi n cube. So we will come to an end of this problems on finite Fourier transform session. So we discussed in detail about the definition of finite Fourier transforms. We focused how to identify whether the given problem comes under finite or not. So depending on x lies between 0 to n. Problems. First we selected find the finite Fourier sine and cosine transforms of f of x equal to sine ax in the interval 0, pi. Here the two cases we did, that is when a equal to n and when a is not equal to n, we concentrated. Two parts we did, Fourier sine 1, Fourier cosine 1. The next problem, that is finite Fourier cosine transform, that is, this is the very, three terms are there. One is constant and algebraic oriented term we have selected. The length of the interval 0 to pi. So we did the differentiation integration. So very simple way of integration also we concentrated using a big algebraic function. The next problem we concentrated, that is, find the finite Fourier sine transform of f of x defined by x. X lies between 0 to pi by 2. The function is x, and if x lies between pi by 2 to pi, the function is pi minus x. That is, 0 to pi is our starting is 0, the ending is L. So our L is pi, but the 0 to L, it has given a break, that is 0 to pi is 0 to pi by 2, the function is x. If it is pi by 2 to pi, the function is pi minus x. In this problem, the three integrals occurred that we integrated, and we did in very detailed way this finite Fourier transforms lecture. Thank you very much to you all. Thank you.